Good day, everyone, and welcome to the third week of the differential equations class. In this week, we are going to talk more about modeling with differential equations. So, before we proceed, please recall that we still have the same book, the same textbook, and if you missed the first 2 weeks, then you probably should stop the lecture now, and you should watch the first two videos, because the material from weeks 1 and 2 is going to be very, very important. So let me make a few remarks. We are working with first order ordinary differential equations. So for instance, second order ordinary differential equations are not of our concern now. Second order differential equations are going to appear in week 5. And partial differential equations are not even a part of our course. It's a different course. In week 2, we learned how to solve separable equations and linear equations. And the main trick to solve both separable equations and linear differential equations is to put them into a special form and then to do integration. Well, the kind of consequence of it is when we do integration, we get this plus c, plus constant. So which means that the general solution of a first order differential equations is always going to contain this parameter that comes from this plus c. Well, the exact implementation of the trick is different. It depends on the class of the equations that you are considering, and there do exist other classes of other types of first order differential equations that can also be solved directly. For instance, homogeneous, exact, and Bernoulli differential equations, but we have not covered them in this class. Well, and the reason is because, well, if you need to solve such an equation in practice, then it's always easier to do it on a computer. So, and the vast majority of differential equations, even first order ordinary differential equations, cannot be solved explicitly, not speaking of second order or systems of differential equations. Well, still, just in order to be able to work with the material, we need to be able to solve some certain classes of differential equations explicitly, linear and separable, for instance. And these two models that we have already seen, free fall in air, is a linear and separable differential equation at the same time, and Newton's law of cooling is also linear and separable at the same time. And I recommend that you try to solve them as linear, and you can try to solve them as separable, and then you will see that it is easier to solve them as linear differential equations. So the method for solving linear differential equations is kind of more simple. But of course, there do exist separable differential equations that are non-linear, so for which we have to use the method for separable differential.